Here's problem number 8 from your Integrated 3 packet that you had for your homework. And so number 8, it says graph and completely describe each of the functions. Be sure to label each graph carefully so that all key points are identified. So we're doing number 8, so I've just written number 8 on the paper here. And what I always do, well, first I look at it and I say, is this one of the parent functions where, like, do I know what this is already going to look like? I know what it's going to look like because I've already taken Integrated 3, but you guys might not necessarily know what this looks like because you've only studied probably linear functions, quadratics, exponential functions. This thing is a reciprocal function, but you don't even need to know that yet because you can graph any function just by plotting some points. So we're going to go ahead and plot some points. This is X and Y. I'll put my arrows on here. And then I always pick the easiest points to plug in, so I just picked -1. Plug in -1, you'll get 2 over 0. So that's undefined. And that's probably what makes this a little bit of a confusing graph for you, because whenever a function is undefined, that means there's a spot where there's some x value that you're not allowed to plug in there without, well, I mean, we can't divide by 0, right? It gives you 2 over 0. So that means that on the graph, there's not going to be any real points at when x is -1, because it gives you a result that is undefined. So what we do is we just show it as a dotted line, and that is called an asymptote. And we'll learn more about asymptotes this year. I realize maybe you don't have much experience with asymptotes. So there's that. But I still want to see my graph. So I'm going to try some other points. 0 is easy to plug in. 0 plus 1 is 1. 2 over 1 is 2, so that's 2. So 0, 2. There's going to be a point there. And then pick a 1, plug a 1 in. 2 over 2, that's 1. So 1, 1. And then, let's see, plug a 2 in. 2, oh, that's 2/3. So 2/3 is well, I'm just going to say it's like right about here. Just kind of eyeball it. Probably not going to be perfect. If I plug a 3 in, well, 3 plus 1 is 4. So 2 over 4, that's a half. So it's a half. So I think I understand what's going to happen. I feel like this is just going to get closer and closer, and it's probably never going to hit this x-axis. If you're not sure, you can plug in, you know, I decided I'll plug in 4. 2 over 4 plus, that's 2/5. Well, 2/5 is smaller than a half, right? So it's just, I don't know if you can use your imagination for this, but the bigger these numbers go, if like I did want to try 5, 6, 7, 8, 9, 10, I'm just going to get a giant number right here. I'm going to have 2 over some big number. So all it's going to do is keep getting smaller and smaller. So now we know that this x-axis is also what we call an asymptote. I'm not going to show it as a dotted line because it's the axis. But so what happens is my graph is going to kind of look like this. And we just show it like it's getting closer and closer, and you've probably seen something like this before because you know about exponential functions, like y equals a times b to the x. Now that's all great and everything, but you have to think to check the other side. Is there any part of this graph that's on the other side? So I'm going to plug in, I want to see, like, if I plug in -2, is that what's going to happen when I plug in -2? So plug in a -2. Just to see how the graph is acting over here. So 2 and then -2 plus 1 is -1. So that's going to be -2, -2. Something like that. Well, I guess I'll just keep going. -3. So -3 plus 1 would be -2. So I think that's going to give me 2 over -2, which is -1. Oh, wait. 1, 2, 3. negative 1. Okay, try negative 4. Negative 4 plus 1 is negative 3. So I've got negative 2/3 there. So now I think a pattern is emerging. See how it goes 2, 1, 2/3, 2, 1. Thinking that's pretty much just how it's going to go. So I don't think I'm going to keep trying. I'll put this one on. Negative 4 and negative 2/3. 2, 3, 4. Negative 2/3. But I can see that it's gonna be kind of just like this one. See the pattern? 2, 1, 2/3, a half, 2/5, 2, 1, 2/3. This would probably be negative a half, negative 2/5 if I kept going. So I can kind of see that there's a little bit of some kind of symmetry going on here. So there's that. You can actually plot the points if you want to. You could even get out a grapher and you could look at it if you wanted to on a graphing calculator. So there's my graph. Now I've been asked to do some things like label each graph carefully. So I'm okay with just, it's pretty clear that this is the y-intercept right here. I mean, I can see because of the grid lines, so I don't think you need to really go, you could go like this, y-intercept if you wanted to, but I feel like that's sufficient. I see clearly that there's an asymptote here. I don't see any x-intercept, so that shows me clearly that there's an asymptote here. So I think I've labeled all my points. What else am I asked to do? I have to completely describe it. So when we describe graphs, we say stuff like whether they're increasing or decreasing. Actually, it's right in here in your packet. I can say the shape and the domain and the range and the endpoints. So sometimes some of this stuff doesn't really apply. Like opening up or downward, it kind of opens to the side and the other side. Increasing and decreasing, it's kind of, I don't know, I guess you could say it's decreasing. Let's check. What does your answer key say? It says, this one's kind of a weird one. But yeah, I would say that it's decreasing because as I move from left to right, even if I'm over here, it's going down, the y values go down. So I'm going to say it's decreasing. It's not linear, so I guess you could say it's curved. You can say there's some other things. We don't want to say opens upward or downward. That would be more like for a parabola. There's the y-intercept right there. I can even say that it's 0, 2. Let's see, domain and range. So domain is all the x values. So if I look at this, I can plug in, or even if I look at my table, I can plug in any x value that I want to, except for -1. So I'll say all real numbers except -1 or something like that. Your book says it like this. Your book says x is just not -1. You can write it like this. And it says the range is not 0, y is not 0, because the range is all the y values. Well, when I follow my graph, do you see, like, this is the only place where y is 0, right there. And see how there's no x value for where y is 0. So if I said range, I would say all the real numbers except 0. So I like how this, I mean, you got your answer key right here. That looks nice. And yeah, so there's asymptotes on this, and you may not have a lot of experience with asymptotes. But basically, since this one goes up and down, it's a vertical asymptote. So let's see, what is that, x? equals -1. And you can do stuff like this so that people can read what you're trying to say. And then I'll say a horizontal asymptote at y equals 0, because this way you have no x values here. Okay, so we'll learn more about asymptotes in class, but I hope that helped you with number 8.